Here is the answer for day 3. What is the wavelength of radiation that has a frequency of 2.5 times 10 to the 13th power hertz? Show the formula, substitutions, and answer. So the formula that applies when a problem involves wavelength and frequency is C equals lambda times nu. This is a Greek letter lambda, and this is a Greek letter nu. The lambda represents the wavelength, and the symbol nu represents the frequency. The letter C is the speed of light. The first thing we need to do in this problem is transform this basic formula so that it has wavelength alone. And wavelength is the lambda symbol. To get the lambda alone, you would divide both sides by the nu. That creates lambda equals C divided by nu. So right here in the box is our formula. Now we're going to make substitutions. In place of the C, write down the number that is always used for speed of light. 2.998 times 10 to the 8th power meters per second. Then we're going to divide by nu, and nu is the frequency. In this problem, we're given that number, 2.5 times 10 to the 13th power hertz. Another way to write hertz is to say per second. Now that we've got our math set up, we're ready to do the work on a calculator. But please notice how the per second and the per second in the bottom cross-cancel away, leaving the symbol m for meters. The other thing you need to know is that on the TI calculators that we use in this class, whenever you divide by a number that's in scientific notation, you're going to need to put that number in parentheses when you type it in the calculator. Otherwise, it's not going to know that you want to divide by this entire number. It's going to think you just want to divide by 2.5, and then you want to times by 10 to the 13th. The result on the calculator is 1.199 times 10 to the negative 5th power. And the label was m, meters. Now let's think about the rounding. The number in the numerator of the division has 1, 2, 3, 4 significant figures. But the number in the denominator has only 2 significant figures, and that limits our answer to 2 significant figures. So we want to round this off to 1.2 times 10 to the negative 5th power meters.